Alright, so last video, this is law of cosines. Once again, we are solving for the missing pieces of a triangle that is not a right triangle. Now, law of cosines is actually derived from the Pythagorean theorem, so it looks really similar, actually, to the Pythagorean theorem. One way of looking at it is if you are solving for either a C side length or a C angle. So if we're solving for a C side length or a C angle, we have C squared is equal to one of the sides that is given information plus the other side that is given information. So in this case, let's say we were given A and B, minus 2 times A times B times cosine of your C. Now this is in a case where you would be solving for angle C, or if you were solving for the side length C. But of course, you wouldn't be solving for both at the same time. You'd probably have to deal with a law of sines in that case. But for example, let's look at an example where we're going to have to solve for A. My triangle, angle A is 40 degrees. We'll give you side C is equal to 20, and side B is equal to 12. And you need to solve for angle A, or side length A, I'm sorry. In this case, the reason you can't use law of sines, well, think about it. You have angle A, but you don't have side length A. You have a side length C, but no angle C. You have a side length B, but no angle B. So this is the reason why we use law of cosines. So law of cosines, another way of looking at it is A squared equals B squared plus C squared minus 2 times B times C times cosine of A. Now we're using this different version of it because in this case we're solving for side length A and we're given angle A. So we go forth with our work. A squared equals, well, B was 12, so I know I have 12 squared. C was 20, so I know I have 20 squared. Minus 2 times 12 times 20 times the cosine of my angle A, which is 40 degrees. So the rest of this is actually pretty nice because we're just plugging in and we're evaluating for A. Now I recognize that A is squared, so later on I'm going to have to take the square root of both sides. So going forth, 12 squared is 144. 20 squared is 400. Minus, so 2 times 12 times 20, that's actually a number of 480. Cosine of 40 degrees, rounded, I'm making sure that I'm in degree mode, is approximately 0.766049. Now, depending upon where you round, this could change your answer from my answer, and of course that'll adjust when you plug it back in to see that it's completely accurate. Okay? Alright, so this is still set equal to A squared. I have not dealt with that fact yet. So A squared, I know I can combine these two because they are like terms. However, I can't just add them into that 480 because this 480 is being multiplied by a quantity. You have to be very careful when you're plugging that in. But 144 plus 400 minus 480 times this nice long decimal, that gets you approximately 176.29888. The last step is to get A completely by itself, so I need to take the square root of both sides. Now I don't need to remember my plus or minus because I can't have a negative value for a side length, just as distance and time are not negative. So when I take the square root, I get that A is approximately 13.27, which you can round to 13 if you so wish. Okay? These types of problem only involve all three sides or only one angle. This is one of those examples where you're solving for that side length because you're given that included angle. Alright, last example for law of cosines. You're given a side triangle where all your side lengths are given. And the question actually reads to you, find the largest angle. Well, it would make sense that the largest angle will be the angle that is across from the largest side. So in that case, 18 is the largest side length. So I'm really looking for angle B. That is really what my x is. So in this case, I'm going to use my B form of my law of cosines equation. B squared is equal to A squared plus C squared minus 2 times A times C times cosine of B. Now in these instances, you're going to have to use your inverse cosine because, well, you're going to have to solve for the angle. So from this point on, you're really just plugging it in. My side length of B is 18, so we have 18 squared. A side length is 9, 9 squared. C length is 12, so we have 12 squared. And I'm just plugging in. My A value is 9, my C value is 12, and I don't know my cosine of B value. That's what I'm solving for. So I go forth. 18 squared is 324. 9 squared is 81. 12 squared is 144. And negative 2 times 9 times 12 is negative 216. Once again, I'm solving for cosine of B. Now these two values cannot go into 216 because 216 is being multiplied by a cosine of B, so I know that they cannot be combined. But I can combine the two of them, 81 and 144, to become 225. So from this point on, it's really just isolating your variable. You're going to subtract 225 from both sides. So then I get 99 is equal to negative 216 times cosine of B. Divide both sides by negative 216. So 99 divided by negative 216, that gives you a decimal of approximately negative 0.4583 equals cosine of B. Now to undo a cosine, you just have to take the cosine inverse of both sides. And cosine inverse of this value, negative 0.4583, that gets you 117.27 degrees approximately for your angle B. Now that's all we are asking for. This question only asks for you to solve for the largest angle, and there it was.